Hello, AI enthusiasts. Last time we had discussed about large language models and how they are trained, and based on the kind of data that they are trained, the kind of fine tuning that they go through, and um, the architectural design, different models acquire different strengths. And we had concluded that whenever we have to design an AI application, the question that we need to ask is what is the problem statement in hand and which model would be the best to solve that specific problem? Now let's zoom out a bit. Uh, we talked about large language models, but they are not just the only aspect about generative AI and the kinds of models that are available. Language is one kind of data that is around us. There are other modalities of data as well, like speech, audio, video, numbers, embeddings, vectors. Think of these models as doctors. You wouldn't go to a dentist for a heart surgery. Similarly, you wouldn't use an image generation model to answer legal queries. So, understanding the model catalog becomes important so that we can make the right choice. Large language models. So this everyone knows. This is your GPT, Opus, Fable, Gemini. These are broad knowledge models, and they can talk to you about anything. They can write emails, they can debug code, and they can absolutely argue with you about pineapple on pizza if you let it. It is the default model, the model that you reach out for first, for about 80% of what you would want AI to do. Now, remember in the last video, I classified models as open weight and closed weight, depending on whether you need a subscription to use them or you can simply download the weights and utilize the model. So for each classification, each kind of model that we're going to talk about today, I am going to list the models that are available under this family, and which of them are available as free or open weight models, and for which of them you require a certain subscription to utilize. Large small language models are the pocket-sized version of the large language models. They differ from the large language models in terms of model size. So large language models often have billions, hundreds of billions of parameters, but small language models would have a few uh, billion parameters. And this might sound like a downgrade, but until you realize that these models can run on your laptop, even on your phone, and are quite fast as compared to the large language models. So whenever you require models, you prefer speed over accuracy. These are the models that you target, and among them, Phi is quite a popular model that is open source and being used uh, in quite some chat devices that you need to run on phone with less latency. So LLMs are trained to predict the next token, given the set of tokens that we have provided them. And if we fine tune LLMs in such a way that they can carry a backend flow conversation, then they are called chat completion models. Such models will give you the feel of uh, remembering a thread, remembering the messages that you have sent so far, so that the user or you don't have to repeat yourself in front of the model. Uh, so these are the models that are quite popular. Your GPT, Gemini, and Claude models are all chat completion models. And you will observe that even if you try to say goodbye to these models, they don't end the conversation there. Reasoning models, these are the ones that actually show you how they are working. Whenever you give them a query, they will not respond instantaneously. They will take a pause, they will do the math in their head, and then they will give a response in a stepwise manner and even explain how they reach to that conclusion. This makes these models a bit slower, but they are way more reliable when you're working a math problem, a code problem, or anything which has a lot of moving parts. So DeepSeek, Quen, uh, these are, and the Claude's extended thinking, are, they all belong to the model family of reasoning models. So far, the family of models that we talked about are very general purpose models in the sense that they can do a variety of tasks. Now, what we're going to talk about is the task specific family of models. These models are trained to accomplish just one job. So they do not do general chat with the user, but are used for achieving a certain task. The first kind of model that I'm going to talk about is the embedding models. The entire job of embedding models is to convert text into numbers, capture meanings, so that a computer can instantly recognize that a dog and a puppy mean the same thing, even though they don't share even a single character in their spellings. This is the engine behind chat with a PDF or uh, every good search bar that you've ever used. Then we have image generation models. These are the fun ones. So their job is to convert text into images. So you can provide any text-based description, however ridiculous to this model, and they will actually turn it into a picture. And sometimes those pictures are equally ridiculous based on the model's performance. So you can describe maybe a golden retriever wearing a cute lab coat. And you don't need a camera, you don't need a painter, you don't even need a lab coat tailor. You will have that image ready in a matter of seconds or minutes. Um, these are really interesting models. Stable Diffusion, Flux, Midjourney. These are quite popular. And I think image generation models are most people's first touch of generative AI. And video generation models, again, this is another fun one. And I'm pretty sure this content is flooding in your feed as of now. While the image generation models, they generate a single image based on the text description that you've provided. Video generation models generate a sequence of images, and while making sure that these images are consistent with each other so that they result in a free-flowing video. So these models can generate short clips from text, or some even take these some still images as the starting and the ending frame and animate uh, the portion in between. And it includes motion, camera moves, and even native audio in it. So if you type in a description like a panda wearing sunglasses and riding a scooter through Mumbai during the
No,
monsoon
no, no,
season, um,
no.
this is what you get. So then we have image analysis models, which work the reverse of what the image generation and video generation models we've seen. These models take an image or media as an input and then give a textual output describing what was there in that image. These models are most utilized in OCR and medical image screening, where you can provide the model with some receipt or an X-ray, and the model then describes or gives an analysis of what the X-ray says, or you can even do question answer based on the image that the model has understood. Text to speech models give audio to text. So they convert text into human like voice by trying to mimic the language that has been spoken, uh, and also the tone involved, the emotion involved in how that piece of text is being converted into the audio. These models are specifically utilized as audiobook narrators and IVR systems, and for providing accessibility to especially able people and as voiceover artists. Then we have the reverse of that, which is the speech to text models. They do the opposite. They capture audio and then convert into text or specific actions as well. So these models are used to summarize your meeting notes. Like they can hear your actual conversations in a meeting and they can create notes out of it. They can create lecture notes, transcriptions, and they can even generate subtitles looking at a video or a movie. And then if you have used voice assistant, the similar kind of models are utilized there. There, instead of generating text, they are used to uh, execute a series of commands that are given through audio. Whisper is a very popular model. Now, all models do not want to be generalists. There are some models that are specifically trained to master a certain language or domain. Like some models are trained in a particular language, and some models are trained to answer queries specific to an industry or a domain. These are some very popular models, and you might have heard these names or have not heard these names. But like Sol LLM, Sol LLM, Sol LLM is a model which can answer queries regarding any legal matter. Biomed LLM will talk about biomedical domain. Servam AI is a platform which is training AI models that are specific to Indian languages. Bloomberg GPT will is a pro in finance. MedPalm will talk about healthcare. GitHub Copilot will talk about code, execution, and deployment. So these models are ones that have traded from being a know-it-all to being a master of one. We have seen a lot of models today, and from where we begin, where we knew about uh, the existence of large language models, the existence of generative AI models, and the question that we began with specifically that when I'm designing my AI application, I frame my problem statement, and then according to that, I think which kind of model do I need to use. Now I've narrowed down your search to a family of models. Next time you think about an application and you define your problem statement like you need a chatbot, then you need a conversational model. If you need to go through lots of PDFs and need to answer questions based on those PDFs, then you will go through, you will think about embedding models. Then, if you need a voiceover, you will search the text to speech models. But uh, as I was going through this video, I was showing you lists of models that are available for um, each of these families. So now the next question that arises is, okay, I have identified my problem statement. I have identified the family of models that I need. Now, among that family of models, which model is the one? So in the next video, I'm going to talk about model benchmarks and which are the four key parameters that you need to look into a model so that you can compare the results of a model and actually narrow down your search to the one. See you in the next video.